Hello, in this video, let's do a circuit simulation in Cadence OrCAD Capture PSPICE. So in this circuit, we have on page 1, here is an operational amplifier that is a gain circuit. It would be the ratio of 100 to 22 plus, some numbers within the expression. And then here's the gain of here's the OpAmp with its own gain circuit that's 100 kilo ohms over 22 kilo ohms. So these gains should roughly be about the same on the outputs of each of these OpAmps. We're going to verify that. Let's go to create a simulation profile. So we go to PSPICE new simulation profile. You can make a DC bias point or transient. What's cool is if you do transient, it's going to calculate the DC bias point already anyway. I'll hit yes because I created this for a version of this file already. So we'll say this is 1 second that it's going to run. We click apply. Now it's going to simulate both circuits, page 1 and page 2, because it's going to simulate this entire root schematic. Okay. And so this is a flat schematic. They're essentially the same schematic, but on different pages. So now we go to PSPICE and we want to place markers at the voltage level and click on here. Then you can go to page 2 and place another voltage marker right on voltage level right here. Then you right click and mode. Then what you do is save that and then you can run your simulation. So go PSPICE, run. You'll get some kind of window out here, but will you see the results? So you need to right click on there, view your results. Still nothing. What we need to do is we need to right click, add trace, and then see what voltages we can see for VU1 out. Okay, you can click OK and it'll show you the output gain. Now what part of the circuit is that? That would be this U1 pin that says out. Okay, that would also be R1 pin number 2, and if you want it for this circuit, it'd be R3 pin number 2. So you can do it that way as well. Let's go to the viewed results. We're gonna right click on this and we're going to add a plot. So now we're going to right click again and add a trace. Let's say I want that voltage of R3 pin number 2, and then it shows on there. Okay, roughly about the same gain. Very interesting, right? Let's go ahead and we can change the color on this thing if we want to. We could say right click, trace property, and then adjust the color to say like a red with a thicker width. Okay, so that it's easier to see, and click OK. And then likewise with the other. Okay, so this is how you would run a simulation on your circuit. As expected, they both have roughly the same gain. If you want more details on how to find the gain, let's go ahead and do it. So we can click on our plot or a trace option, go to cursor, then display, and then choose the trace that we like, choose the value that we want, or trace that we want, and that would be VR3 as indicated by these dotted lines or across here. And whether you use the right mouse button or the left mouse button to move your cursor, you can look down here. Cursors 1 and 2, they both have this negative 2.2646 value. We're going to Control C to copy that, pull up our calculator, and we're going to Control V to paste that. Now we need to divide this by the input voltage to the circuit. If you might have missed it, the input voltage is 500 millivolts, which is half a volt. So we divide that by 0.5. This gives us a gain of negative 4.529 thereabout for the second circuit. And then likewise, if you do it for the first circuit, let's say you go in here and then start moving cursors around on this circuit, then you get roughly about the same. That's going to be, about the same, 2.27, Control copy and paste that in there. Control V, paste, divided by 0.5, 4.545. So the gain is different. There is some adjustment there. There's some change, and that's because the gain is not strictly proportional to just the resistor values. There's another little bit of factor in there as well as far as the gain. Okay, so that's how you run a simulation in OrCAD, and thanks for watching.